Okay, so today we're going to be doing a classic math problem. We're going to be summing the natural numbers from 1 to 100. And then of course we're going to be generalizing to any n, right? So there's a legend where Gauss, a famous mathematician, when he was a child, his teacher would make the class sum up a bunch of natural numbers in this way, and Gauss came up with a formula to give him the answer directly without having to sum every single number. So, the first thing we do is we'll give this sum a name, okay? It's always a good idea to give something you don't know a name in math. So we're going to call it S, and first thing we might notice is that S is the same thing forwards as backwards. So this sum can be written like this. And it'll have the same value of S, it's just written backwards. And of course, it's commutative, so it all works out. So if these are the same, we could try doing S plus S, which is 2S, but we could add these two equations. So you get 1 times plus 100, so you get 101, 2 plus 99, we get 101, 3 plus 98, 101, and actually they all turn out to be 101. Pretty cool how they all just turn into 101 when you sum them. And this will become more clear when we generalize to n, why they all cancel out to be 101. So let's continue. How many 101s are being added together? Well, that's just 100. And then to finally solve it, you have to divide out by 2, so we get the final answer of this. So this will just be 5,050. It's relatively easy to compute. So now your original sum is just 5,050. Pretty cool, right? So let's go ahead and generalize, because why not? So generalizing, we'll have n, and then we could also write the previous term before it, n minus 1, previous term before that, n minus 2. Okay? This is S, and we'll do the same trick of reversing the order. So now we'll have n, and then n minus 1, and then n minus 2, then n minus 3, on and on. And then here we'll get 3 plus 2 plus 1. Okay, summing these two, we get 2s is going to be n plus 1, plus n plus 1, plus n plus 1, plus n plus 1, all the way to the end, right? And now we can do how many n plus 1s are there? There are exactly n plus 1s. And then we could divide out by 2 on both sides. And there we go. And one fancy shorthand for the sum notation is this. We could write the Greek letter sigma, and then we come up with some dummy variable I. Starts at 1, goes up to n, and we just add up all the i's. So there we go. We got our formula for the sum of natural numbers. Okay, and it definitely stops at some point. Doesn't go on to infinity. There's like, okay, yeah.